All right, like I said, this episode is especially for Mirror, and I want to focus on Fourier analysis and function analysis. So, what is more important than for Fourier analysis than trigonometry? That's why maybe I want to start with this book by Elie Mahor, Trigonometric Delights. So it covers all kinds of fun things with trigonometry. Ancient Egypt, we have a trigonometric table. Johann Muller, François Viette, Abraham de Moivre, Agnesi, Lisa Joux and the curves, tangent x, Fourier's theorem, and yeah, some appendices. So here's the Rin Papyrus. And yeah, it covers all kind of neat stuff to do with trigonometry from history. So, and it does it pretty well. It's actually a very interesting book. I think this would absolutely be a perfect book for like children who are into mathematics or who want to get into mathematics. But it also covers a lot of fun history, which could be interesting even for professionals, I guess. So yeah, there's a companion volume to this because trigonometry, Fourier series will only really work with Pythagorean theorem, and so there is this companion volume by the same person on the Pythagorean theorem, and a 4,000-year history on the Pythagorean theorem. So it started with Mesopotamia, Pythagoras, Euclid's Elements, Archimedes, Viette, infinite and infinitesimal, 371 proofs, strange coordinates and notation, flat space to curved spacetime, and then relativity and universality. So yeah, a similar book on the history of the Pythagorean theorem and how everything is used and how everything is being done. Very fun book to read through. Kind of a bedtime reading book on the Pythagorean theorem and everything the way it's used. So yeah, I mean, read it before you go to sleep. It's absolutely perfect for this. So yeah. Also, again, for children who are know you are into math, this would be a pretty good book. Anyway, now Hilbert spaces originally come not from Hilbert, but they come from a person. I don't know if you know him, but he's called von Neumann. And von Neumann is known for rigorously defining quantum mechanics, and that's where his book is from, Mathematical Foundation of Quantum Mechanics. It is actually the first book that works with Hilbert spaces, or that defines Hilbert spaces in the way that it's being used. So it deals with abstract Hilbert spaces, it deals with quantum statistics, then it goes on to deductive development of the theory, general constitution, and the measuring process. So yeah, it's a translation of his old book, and I think it's still very readable, especially for people, and it really shows his thought process of why he came to see Hilbert spaces and function analysis as an important subject. So you see here you can recognize the L2 space, and it develops all of these things of Hilbert spaces. And I don't really think he called them Hilbert space at that point. He's probably calling them something like a space of type C or something. But yeah, it's a very cool book. It really shows his thought process of how he came up with these things and how it's being used in quantum mechanics. So yeah. Here is this book, A First Course in Harmonic Analysis by Anton Deitmar. Yeah, which is covering Fourier series in the beginning. then Hilbert spaces, the Fourier transform, distributions, finite abelian groups, LCA groups, the dual group, Plancherel's theorem, matrix groups, representation of SU2, the Peter-Weyl theorem, and then the Heisenberg group. That's everything it covers. I guess it's kind of alternative, maybe a higher level alternative, like Stein-Sekarki. And just like that book, it doesn't really use measure theory in this book. It only really works with Riemann integrable, which I think is a bit of a shame. I think that, yeah, don't really like that for obvious reasons, even though it does work, I guess. And it doesn't need the full machinery of measure spaces. So yeah, I think it's a very nice book. Very nice introduction with a lot of fun themes, especially the abstracts harmonic analysis in here is very fun and very cool to do. So yeah. Next we come to maybe my favorite book on function analysis. It's this one by Peter Lachs, Function Analysis. Very good printing, very good pages. Love these pages. So it covers a lot of different topics. So it starts with linear spaces, linear maps, goes on to the Hahn-Banach theory, application of the Hahn-Banach theorem, normed linear spaces, Hilbert spaces, application of Hilbert space results, including the Radon-Nikodym theorem, by the way, duals of normed linear spaces, applications of duality, weak convergence, application of weak convergence, weak and weak star topologies, locally convex topologies and the Krein-Milman theorem and the extreme points, bounded linear maps, examples, Banach algebras and their elementary spectral theory, Gelfand's theory of commutative Banach algebras, applications of it, examples of operators and their spectra, compact maps, examples of compact operators, positive compact operators, Fredholm's theory of integral equations, invariant subspaces, harmonic analysis on a half-line. Then we come to index theory, compact symmetric operators in Hilbert space, examples of compact symmetric operators, trace class and trace formula. Then spectral theory of symmetric normal and unitary operators, of self-adjoint operators, examples, semigroups of operators, groups of unitary operators, examples of strong continuous semigroups, scattering theory, a theorem by Berling, and then two very interesting appendices on the Rieske-Coetani representation theorem and a theorem of the theory of distributions. So I love this book and I love the exercise in this book, even though they're pretty hard. All the chapters are pretty short, on a short side, and they're heavily motivated by applications in analysis, of course. For example, one topic I really like in this book is the Fredholm theory, where he works out the theory of integral equations, which was originally the very purpose of function analysis. So, and it's one of the only books that I've really seen work this thing out. Most other books kind of skip this at this point because I guess it's not really relevant anymore. But I still think it's very nice. Yeah, it's just a joy to go through this book. Next, we come to a book on classical Fourier analysis by Grafakos. He also has this companion volume on modern Fourier analysis. So we have here LP spaces, maximal functions, Fourier transforms and distributions, Fourier analysis on the torus, singular integrals of convolution type, Littlewood-Paley theory and multipliers, and then appendices on gamma and beta functions, Bessel functions, Rademacher functions, and so on. So yeah, a very hardcore book, I would say. Goes right into the weeds with LP spaces and on various, for me at least, very non-trivial theorems. But yeah, I guess if you're into this hardcore Fourier analysis type of stuff, you will really like this one. So yeah, very, very good and rigorous book. I guess Mirror has used it already for his qualifier exam. Right, next come a very famous book on function analysis and or Fourier analysis, especially. It's Fourier Analysis and Self-Adjointness by Reed and Simon. So it starts with the Fourier transform, and then it goes on to self-adjointness and the existence of dynamics, where it goes all into quantum mechanics and how Fourier analysis is used in there. So it's only 2 chapters in this book. Very, very nicely written, of course, as you would expect of a Reed and Simon book. There's some next volumes, but I guess they become less and less interesting. But yeah, it really goes into Hamiltonians and everything to do with that, and what the different spectra mean in quantum mechanics. So yeah, I very much enjoy a book like this, especially since it's very physically motivated. Next we come to some excellent books on Fourier analysis. We have here Corner's Fourier analysis, and then we have here an exercise volume filled with all kinds of very non-trivial exercises. So Corner's Fourier analysis, it does Fourier series, does some differential equations, orthogonal series, Fourier transforms, further developments, and other directions. And they're pretty short chapters, all dealing with some pretty non-trivial subject on Fourier series. The exercises are particularly good and hellish. Many I couldn't solve because they're so hard. But yeah, it's excellently written. Corner is an excellent writer. And he really makes the subject seem a lot of fun. There's a lot of applications in here too, like the age of the Earth is a possible application. Isoperimetric problem is a possible application of this stuff. Sturm-Liouville equations and so on. So yeah, very cool book. Exercises which are particularly hard. But yeah, there's a lot of exercise statements in this book. Very, very cool. Very cool stuff. And then the final book to present today is Fourier Analysis and its Applications by Volland. Yes, that's the Volland who also has a book on real analysis of a graduate book. So we see here Fourier series, orthogonal set of functions, boundary value problems, Bessel functions, orthogonal polynomials, Fourier transform, Laplace transform, generalized functions, and Green functions. So yeah, a rather introductory book to Fourier series on an undergrad level, but still very worthwhile, still very fun. It really does cover topics and do it a lot of justice, including the applications. I guess it's an alternative to Stein-Sakarcki, and I know Mirror is not going to be persuaded to drop Stein-Sakarcki because of this, but I still think this is a very good book. Very fun book to work through. So yeah, that concludes it for today.